This is my project which I have pushed to the GitLab repo. Here I have two folders, app and Terraform. So the app folder has the source code for each respective container, and the Terraform folder has the Terraform script which I'll be running on the Google Cloud Platform. So I'll quickly go through the script first. Here we have the provider block. This block is used to specify and configure the cloud provider, which is a GCP in this case, and the project and the region are specified here. Then we have the Google Container Cluster resource, and this block is used to create the GKE cluster. The name and the location of the cluster is specified here, and I have used the remove default node pull to true, which means that the default node pull created by the GKE will be removed. Then we have the Google Container Node Pull resource. This block is used to create a node pull within the previously created cluster, and here the node config block is used to specify the configuration of the nodes in the node pull. This includes the machine type, the disk type, and the image type, etc. kind of properties, and all this adheres to the requirements mentioned in the assignment. And the last resource which I have created is the persistent disk. So I'll quickly run this script on my Cloud Shell. I already have the main.tf, like the Terraform script, uploaded on my Cloud Shell. So I'll just so now I have applied my Terraform script on the Google Cloud Shell. This process takes around 10 minutes, so I'll pause my video here and continue after the resources are provisioned. Right, so the script ran successfully, and we can see that all in all 3 resources were provisioned, which were mentioned in the Terraform script. So now let's see if the cluster was created. So we can see that the cluster is up and running now. Let's also check if there are any workloads running on this cluster. So we can see that there are no workloads running for that cluster currently. Now moving on to the next part, which is the CI/CD pipeline on the GCP. Here, all in all, I have 2 repositories for container 1 and container 2, and I have used Cloud Build in order to implement the CI/CD process. So here the very first step is building the container image. I am using Docker file to build the image, and then the next step is pushing the image to the container registry, which is the artifact registry in our case, and the later steps are deploying the image to the cluster, and this is done by the deployment.yaml file. So here the very first step is creating a persistent volume, which is of 1 GB storage, and I have also specified the read and write permissions. Then we have the persistent volume claim, which is required to request for the PV which we just created above, and then we have the deployment object, which will run the container 1 in the pod, and we have all the container related configuration specified in the deployment object. And lastly, we have the service. So this service will basically expose the container 1 to the internet, and similarly all those configurations goes for container 2 as well. And this is the artifact registry, so I'll just show you that. So yeah, we have the images for respective containers pushed over here, And in order to automate the CI/CD process on code push to the main branch, I have used triggers, which basically watches for changes and runs the cloud build, which we have specified in each repository. And now I'll make the changes to the repo to demonstrate the complete CI/CD process. So as we can see that the changes were detected, and as soon as the changes were made to the respective repositories, the triggers ran, and the deployment started for each container. Alright, so the deployment for container 1 was successful, and so was for container 2. And if we see the images, they were updated just now. Now moving on to the third step, which is running of the workloads in the cluster. So initially there were no clusters created, but if we see now, the deployment of each container was done onto the cluster, and each the cluster for container 1 and container 2 started. So the pods are getting created for both the containers. So after a successful build and deployment process, which took around 4 to 5 minutes, we can see that 2 workloads are up and running in our cluster, and each workload is serving the pods, and each pod is running our respective containers. So now moving on to the last part, which is working of all the APIs. So I'll test my APIs with Postman to get a score, and here I have used service 1 to expose my container 1 to the internet. So I'll just paste the service 1's IP in the request and check my score. I have exposed my service to port 6000. So it says that I have passed all of my test cases, which means that all the requests which were mentioned in the assignment documents are satisfied. And yeah, so I got a final score, and all of my test cases are passed. The last and very important step is to destroy all the resources which we have created. We can use Terraform destroy command in order to destroy all the resources which we created using the Terraform script. And we can see that we created 3 resources using the Terraform script, and those resources are destroyed now. So in this part of the video, I want to show how the file is getting stored in the persistent volume. So I have both of my workloads up and running now, and the respective pods are also running. So I have exposed my container 1 with the help of service 1, and I'll show you with the help of kubectl whether there are any files inside the persistent volume as of now or not. So we have 2 pods up and running now, and Okay, so we are inside the pod 1, and so this is the directory which is attached to this pod, and this is a shared directory which is shared between both the pods. So I'm inside that directory right now, and as we can see, there are no files which are stored inside this directory right now. And let's verify that for the pod 2 as well. Alright, so we'll repeat the same thing. Yeah, so we can see that since it's a shared storage, we don't have any files in that directory right now. Now I'll make a call to the service. Alright, so all of my test cases are passed now, and I got a score as well. And now let's see if any files were stored in the shared storage. Yeah, so 2 files were stored in the shared directory, and let's verify if this is the case with the second pod as well. Yeah, so the same files are stored in the same directory, since this directory is shared between both the pods.